In the Johnson Space Center, JSC, there is a flag on top of the building whenever an American is in space. For the last 21 years, there was always a flag. So they just changed because of the town, but at the end of the day, they never put it up and down anymore for the last 21 years. The whole complex is dedicated to human spaceflight. And it's true that it's motivating people. It's really connecting us to space as a human when we know that there is another human that is orbiting Earth or going outside or going to the moon. But at the end of the day, bottom line, when we want to do something in space, most of the time sending robot or machines is more efficient, especially for deep space exploration. But the amount of satellite out there full of technology and electronics and computing power today that are capable of helping us on Earth is amazing. And it's not because of human working there, it's really because of all those machines that we send into space. One thing that is really important to know that is not well known is that a lot of the design, a lot of the structure and a lot of the strength of the satellite are built to sustain the launch. During a launch, there is some 6, 8, sometimes even more than that, G's force on the actual system and the actual satellite with a lot of vibration, and it's a strong event. So the machine is suffering during the launch to actually get to space. And there is a lot of the structural load, a lot of the construction, a lot of the materials and carbon fiber, aluminum connections that are actually getting bigger and heavier just because of the launch. This doesn't make any sense, because once the satellite is in space, the actual stress and the actual constraints of the thrusters and of the kind of events that will happen to the system in space are order of magnitude smaller than what it will survive during the launch. For example, lately in the International Space Station, there was the Nauka module from the Russian that got connected, and it continued to fire its thrusters. And if you think about it, on Earth, there is this huge football-length size structure of metal and modules, and there is at the end of it almost one module that is pushing the thrusters and started to flip the whole space station around its center of gravity. The stress on the structure was really minimal compared to what those modules went through when they went through launches. And the next generation of space industry and the space satellite will be to actually create satellite directly in space. And we have company already starting to create this environment, because the amount of kilograms and the amount of materials and the efficiency, if you create directly in microgravity a full satellite or a full probe, is order of magnitude. It's a lot lighter, a lot more efficient to push around and to have the thrust and the forces correctly set in microgravity and in space. The main issue is that we need to send humans to do that. It's still the best machine that we have to be able to create more complicated machines. So the future of space and the future of space vehicle and spacecraft is to actually make them in space. We need to send the raw material to space and have space factory that can create all the space hardware that we need. So we can create way lighter and way more performant satellite in space and create what we need, especially for the deep space exploration and environment. And there is a lot of company and a lot of startup and a lot of energy toward this, but this is the future. We need to create our space hardware in space and not have to make them built for launches. And so we are looking forward to a time where there will be space factory in low Earth orbit capable of building high-tech satellite and high-tech probe to reach the outermost of the solar system.